Hi you guys, welcome to today's lesson. This lesson is on the properties of parallelograms. First of all, a parallelogram, which I'm going to call a p-gram throughout the rest of this time here, is a quadrilateral with both pairs of opposite sides parallel. So when we're doing this here, I know I can say QP is parallel to RS, and notice that right there is the symbol for parallel. It's kind of like a slanted 11. I can also say then QR is parallel to PS. So if we look at this figure right here, another way we can show parallel on the actual figure is I can say UA is parallel to QD, and I'm going to use a different one because I don't want to say, I know that these are not parallel. QU is parallel to AD. So you can either write it out with the symbol between the two, or you can put the arrows on the lines there showing opposite sides are parallel. So that's the first part of a parallelogram. The opposite sides are parallel. So if we have a quadrilateral that's a parallelogram, then its opposite sides are also congruent, and there's the symbol for congruent right there. So I have QP is congruent to RS. I also have QR is congruent to PS. So I can definitely show, I can say, hey, fine, I can do those two are congruent, and I can do a third mark here to show those two are congruent if we were actually marking a figure. Some of the problems you're going to get show right here. So if I know that this is a parallelogram, I do because the opposite sides are parallel, given the triangles I'm marking there, showing the opposite sides are parallel. This is 3, so I know that's 3, and that is 5. I could also then ask you, hey, what's the perimeter of that parallelogram? And you would tell me that it's 16. Same thing over here. That would be 8. That would be 12. So now we've got two things. Opposite sides are parallel, and the opposite sides are also congruent. The third part of a parallelogram is that the opposite angles are also congruent. That is this right here. So I can say angle Q is congruent to angle S, and angle P is congruent to angle R. So knowing that, in a parallelogram quad, find the measure of the missing angles. I know my opposite angles are congruent, so that is 70 degrees, and that is 110. Hey, this is a parallelogram. I know it because of the markings, so this is 120 degrees right there, and that is 60 degrees right there. So we've got opposite sides are parallel, opposite sides are congruent, and the opposite angles are congruent for right now. The fourth property of a parallelogram is that its consecutive angles are also supplementary, which, remember, that means they add to 180 degrees. So you can kind of apply two things here. If I know that this is 50 degrees and this is a parallelogram based off the markings, 180 minus that 50 degrees gives me 130 degrees right here. And then 180 minus 50 this way as well, this is also 130 degrees. Now that's the supplementary part of it. But we can also remember that the opposite angles are congruent, so we know if this is 50, we know this angle's 50. So let's try that again. If I know this angle here is 105, I know this angle here is 105. And then this one here should be 180 minus 105, which gives you 75 right here. But if this is 75, we know the opposite angle from it is also 75. So again, we've got opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, and now we have consecutive angles are supplementary. And let's remember that consecutive angles are angles that are immediately next to each other, like angle N and angle M. And then the fifth property of a parallelogram is that the diagonals of a parallelogram bisect each other. Remember, bisect means to cut in half. So I know that QM is congruent to MS, and I know that PM is congruent to MR. And notice again I used two different types of tick marks because these diagonals are not congruent to each other. So I know just this part here is congruent to that one, and just that part here is congruent to that. So if we see how that is, I know if this is 7, I know that part there is 7. Now notice it also asks for JK, so we know JK is equal to 7. But it also asks for JG, the whole diagonal. Well, we can look at if this is 7, this is 7. 7 plus the other 7 here, that whole diagonal is 14. So sometimes you're given the figures marked, other times you actually have to go ahead and mark the figures. So it says here in the parallelogram, so I know that this is congruent to that and that's congruent to that. It says FH is 16, so this whole diagonal is 16. Remember, diagonals are cut in half in a parallelogram, so that's 8 and that's 8. It also says JK is 6, so I'm going to mark that one as 6. But if this part here, JK is 6, we know KG is 6. And then it asks for KF. So KF, so I just have to find it on the figure. KF, okay, that's 8. KH is that part, so that's 8. KG, that's this part down here, that's 6. And then JG, this part over here, that whole thing is 12. So again, here are the 5 properties. I refer to them as the Fab 5. Definition of a parallelogram: the opposite sides are parallel. What else do we know about the opposite sides? The opposite sides are congruent. We'll use the nice congruent symbol for that. The opposite angles in a parallelogram are congruent, and notice I use a nice angle symbol for that. The consecutive angles are supplementary. We can also put equal 180 degrees. And then the last part is the diagonals bisect each other in a parallelogram. And remember, bisect means to cut in half. Now there were a couple problems that we looked at up above as far as examples. I want to go back to these right here. So the opposite sides are congruent, so I know that this is 8, I know that's 8 right there because those are congruent, and this is congruent to that, so that's 10. So again, I could ask you what is the perimeter of this parallelogram, and I would say that that's 36. Sometimes you're going to be given information that actually makes you write an equation. So I know this is congruent to that, so now I have 2x minus 1 is equal to 11. So I add 1 to both sides. 2x equals 12. Divide by 2 from both sides, and x equals 6. And then I know that this is congruent to that, so 3y plus 4 is equal to 13. So subtract 4 from both sides. Divide by 3 from both sides, and I get y is equal to 3. Sometimes the problem might say, give me the value of the variable. Great, we're done. X equals 6 and y equals 3. Other times it might say, tell me then what is the length of AD. Oh, that's already 11. We've already got that. Which also means then, based off of that, I can find UQ in one way, or two ways. The easy way is knowing that the opposite sides are congruent, so if this is 11, we know this is 11. But I could take my value for x and plug it in. 2 times 6 is 12. 12 minus 1 is 11. Again, it might say, what is the length of QD? Where if we're paying attention, I know that if UA is 13, QD has to be 13. But I can also use the value of my variable, plug in 3. 3 times 3 is 9. 9 plus 4 is 13. Again, so that little last recap for all the properties. Scroll down here to the bottom. Opposite sides are parallel. opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, which means they add to 180, and the diagonals bisect each other. Those are the Fab 5 properties of a parallelogram.